Example 4. Calculate the mass of released carbon dioxide in grams from burning of 500 grams of C8H18, okay, according to the following equation. So, the missing here, the mass of CO2, which is right here, okay? And we have 500 grams of C8H18, okay? What I want to do here is that to find out the mass of any substance. So in order to get a mass, there's like a law, which is normality equals mass over the molecular mass. So number of moles is missing, right? Mass is also missing for the required substance or gas, and the molar mass. So molar mass is right here. So first of all, we want to calculate the molar mass of any substance, which is this one. How to do that? So it's C8H18. In order to do so, you are going to be giving like the mass or the molar mass of carbon and hydrogen. For the carbon, it's 12, okay? It will be giving the example on the question. For the hydrogen, it is 1. So what are we going to do here is that how many carbon atom right here in the equation? We have, on the formula, we have 8. So we are going to multiply 8 times 12, okay? As it's shown here, right? Plus, we have only hydrogen right here. So we say 18 hydrogen times what? 1. So 18 times 1, it gives us 114 grams per mole, which is the mass or the molar mass of the whole compound or of the C8H18. So this is how you like calculate the molar mass of any substance. So you see like how many atoms of one singular elements in the formula, and then you multiply by the mass or the molar mass of the giving formula. So you are going to get everything ready. So your job is to just find out the how many atoms in this in the formula and multiply by that number. Okay, this is first step. The second step is to find out or to like use the law, which is normality equals mass over molecular mass. So this is for what? For C8H18. So now we have not done anything regarding the missing the CO2. So in the question it says we want to calculate the mass of CO2, okay? However, we don't have any information or any giving numbers regarding the CO2, but we do have the mass of C8H18. So what we are going to do here is that we are not allowed, or there's no like law so far that would be like combining or could be depending on to find the mass of a substance by depending on the mass of other substance. However, as we mentioned in the previous slide, we do have a law that explains or show how we can find out a number of moles of a substance using the number of moles of other substance. So for this like matter or for this problem, we are going to find out the number of moles of C8H18 by using this law, okay? Normality is equals mass over molecular mass, and then from the number of moles, okay, of C8H18, we will be using it to find out the number of moles of what? Of the CO2, and then from the number of moles of CO2, we will find out the number of or the mass of CO2. It's kind of like a connection between them. So now, the number of moles of 500 is given in the question. 114 is given, or the one that we just calculated. We got the number of moles of C8H18. Now, let's move to the Second one, after we got the number of moles of C8H18, we will be using this value to find out the number of moles of CO2. Okay, number of moles of CO2 equals the number of moles of C8H18 times the number of moles in the equation, which is 16 for the CO2, okay, and 2 moles for the C8H18, and then we got the number of moles of what? Of the CO2. Now we need to calculate the mass. So from the gram, so you have this sketch right here. From the gram, we got the moles of C8H18, and from here we got the moles of CO2, and then from the CO2 we got the grams of CO2. Okay, this is the step that we have been following, right? And the same thing, mass is equals, or normality equals mass over molecular mass, and the same thing here. This is law that we have used before, okay? And we got the grams of CO2, which is the missing. You gotta or you should do it by using a pen and a piece of paper in order to know what you have done. So you go through the steps, each one individually, and then you do it yourself, and then you can check with the examples in the textbook. Now let's move to this example. One of the components of acid rain is nitric acid, in which the reaction of NO2 with oxygen and rain water, according to the following equation. We have this equation. So first of all, what is required from us to do here is to calculate the amount of HNO3 produced from the reaction of 1,500 grams of NO2, the same as the previous example. So we are giving the mass of NO2, and what is required here is the mass, or the amount. When you say amount, it means the mass. Okay, the mass of HNO3. So what we are going to do, we will find out the number of moles of NO2, okay, number of moles of NO2, and from the number of moles of NO2 we will be finding out the number of moles of what? Of the HNO3, and then from the HNO3 we find the mass of HNO3. So let's go through it. So first of all, we will be using or finding out the molar mass of the NO2. So what we will be giving in the question is the mass, or the molar mass of the elements. Nitrogen is gonna be 14. Excuse me for the bad writing, because I'm using the mouse of my laptop to do that. And for the oxygen is 16. So you go to the NO2. For the NO2, we have how many nitrogen atoms right here? Only one. So 14 times 1, or 1 times 14, which is right here, okay? Plus, how many oxygen? We have 2 atoms of oxygen. So 2 times 16, which is right here. So the total will be 46 grams per mole. After that, as we mentioned, we calculate the normality of the NO2, the same as the previous one, mass over molar mass, which is 32.6 moles of NO2, and then from the moles of NO2 we calculate the number of moles of the HNO3, the same thing right here. So the one that we just calculated times the moles of the HNO3 from the equation, which is 4 moles, and number of moles of NO2 from the equation, which is 4 moles, gives us 32.6 moles of HNO3. The third step is to use that moles of HNO3, and we can use the law, which is normality equals mass over molecular mass, and we can get the mass of the HNO3 right here. Okay, so I want you to do the exercise in the previous slides, okay, exercise 4, and then until next time I want you to read this, study it very carefully, okay, And if you have any question, feel free to ask in the group, okay? And we will be continuing doing or finishing the rest of the chapter in the next or in the upcoming lectures. See you then.